Hi everyone, here is a video going through some of the problems on the review guide for ionic bonding. Now first, we're going to skip the sodium and chlorine problem. We've done this one a lot in class. You can probably find notes and worksheets going through this problem. So I'm going to start out with magnesium and oxygen. Now I highly recommend that you try this problem before I go through it. So if you haven't attempted this yet, go ahead, pause the video. When you're finished, replay it. Now, so to start off, we are just going to start with one magnesium and one oxygen. And we're going to draw in the valence electrons for each. So magnesium has 2 valence electrons, oxygen has 6. And then our next step is to draw the arrows showing the transfer of electrons. So each dot on the metal, in that case this is magnesium, needs to have an arrow. Okay, you have to have, so if I have 2 dots, I'm going to have 2 arrows. Now, after I have transferred my electrons, I find that oxygen is going to end up with 8 and be nice and happy, and magnesium is able to get rid of all of its electrons, okay? So then we move on to our next step, where we show what happens after all the electrons have been transferred. So again, magnesium is going to end up with 0 valence electrons, and oxygen is going to have 8. Right? And then we have to put our ions in brackets. All right, so remember, now that they have changed the number of electrons that they have, these atoms are going to become ions, so we put them in brackets. And we give them their charges. Magnesium is a metal, so it will have a positive charge. It lost 2 electrons, so it will be +2, whereas oxygen is a non-metal. It will have a negative charge, and it gained 2 electrons, okay? And then the last step, so make sure you read the directions because it does ask to include the final compound formula. In this case, I have one of each ion, so my final formula is just MgO. All right, so that was the first problem. We are going to do the next problem of potassium and sulfur. All right, again, if you have not done this problem with potassium and sulfur, I highly recommend you pause the video and try the problem yourself. So again, we're going to start out with 1 potassium and 1 sulfur. Potassium has 1 valence electron and sulfur has 6. And remember, I still am only going to start out with 1 of each. So then I draw an arrow showing my transfer of electrons. And here is where this problem differs from magnesium and oxygen. So you can see we have the arrow of potassium's 1 valence electron going to sulfur. And while potassium is going to be nice and happy, it's losing its valence electron. Sulfur is only going to end up with 7. It still has space at the bottom here for another electron, okay? So sulfur's not going to be happy at this point. So in order to make it happy, I can only add either more potassiums or more sulfurs. So if I want to make sulfur happy, I need to add another potassium with 1 valence electron. And once I do that, I'm able to transfer that electron to sulfur. Now both of my potassiums are going to be happy, and now my sulfur is going to be happy. So then we move on to the next step. Now, another thing is that you need to rewrite the same number of atoms after the arrow. So if I have 2 potassiums, I have to write out two separate potassiums, okay? I can't combine them. I can't join them together, okay? They're two separate potassiums. And then I have one sulfur still. So again, my potassiums lost their valence electrons, sulfur gained them. So now they're ions, we put them in brackets, and we write their charges. Now, each potassium is separate, so they each lost one electron, so they will each have a +1 charge, where sulfur has a -2. One way to check that you did your work correctly, or you have the correct number of each atom, is that you add up the charges, so +1 + 1 -2, that should equal 0. If you find it doesn't equal 0, something went wrong. All right, so then my final formula, because I have 2 potassiums, I give it a subscript of 2, S. Okay. Now we're gonna move on to aluminum and oxygen. Calcium and chlorine is pretty similar to the potassium and sulfur problem. Aluminum and oxygen is a little more tricky and probably the most complicated Lewis dot structure or type of Lewis dot structure you'll see on the Ionic test. So again, we're going to start out this problem like we have with all the other ones, with adding 1 aluminum and 1 oxygen with their valence electrons. All right, and then we're going to add the arrows to show the transfer of electrons. So aluminum has 3 valence electrons. Oxygen has 6, so you can probably see, again, we're going to end up with an unhappy aluminum with an extra valence electron. In order to solve that, I need to get rid of it. To do that, I'm going to have to add another oxygen. So I'm going to add an oxygen with 6 valence electrons, like the last one. Now I can finally get rid of that aluminum valence electron. But now I still have a problem because now my new oxygen isn't going to be happy. Okay, it's still able to gain another electron. So to solve that, I'm adding another aluminum. And you might have guessed it, but I am still going to have a problem with an unhappy aluminum again. Okay, it has 2 valence electrons that I can still get rid of. So I'm adding another oxygen with 6 valence electrons. Oops, I did not write that. There we go. So this is where it's really important to keep your work organized and make sure you are being very clear with your dots and arrows, because if it all looks mixed together, it's kind of unclear what you're doing. So now I'm just going to double check that all of my aluminums are getting rid of their valence electrons and all my oxygens are gaining valence electrons. And it looks good, so I'm going to move on to the next step. So I'm going to just write out the same number of atoms that I had before the arrow. So I had 2 aluminums, 3 oxygens, and I'm going to give all of my oxygens 8 valence electrons. And once I've done that, I put all of my ions in brackets. And my last step is to give them charges. So again, my metals will have a positive charge, and aluminum lost 3 valence electrons, so it will have a +3. My non-metals all have negative charges, and they all gained 2 valence electrons, so they will have a -2 charge. And my final formula is going to be Al2, because I have 2 aluminums, O3. So it's also really important that you are very clear about your subscripts. They're called subscripts. So sub, okay, sub means kind of like under. All right, so you really need to make sure that that number is kind of below or under the element symbol, okay? If you put it above, that means something different, all right? And that is not going to give you the points that you want. If you also just give it like a regular number and put it in the middle here, that also means something different. So make sure you are very clear and you are writing very organized. All right, here we have the second page. This is all about naming and writing formulas. So my best advice when you start problems like this, organize it with identifying your acids versus your ionic compounds, okay? It does tell you that there are a mix of acids and ionic compounds, okay? So first organize which is which. So just go through and just write like an A next to the problems that are acids. If you don't remember, acids are anything that start with an H, okay? So in this first left-hand column, I'm just gonna go through and write an A next to anything that starts with an H. All right, it looks like I got them all. So the ones that don't start with an H, those are all ionic compounds, because those are the only 2 that we've learned to name. On the right-hand column, it's a little easier to figure out which ones are acids, because they end with the word acid. All right, now since I've started talking about acids, I'm just going to keep going with naming them. And once I'm done with those, I will continue with ionic compounds. So your probably simplest naming for acids are ones where it is just 2 elements, an H and something else. Okay, so that is the binary acid. Okay, binary means 2. So 2 elements in the acid. When we have a binary acid, we always start with hydro, and then we write the name of the non-metal, so whatever is bonded to that hydrogen, and change the ending to ic. So it would be hydrochloric acid. All right, don't forget about the word acid at the end. You need to have that. So then this other one, HF, is going to be hydrofluoric acid. All right. Now these other types of acids, so when you have multiple elements, like this first acid here, you have an H, you have an N, and you have an O. That means that you are going to be looking at the back of your periodic table for the polyatomic list that we have, all right? So this is a little more complicated. So you are going to go look for NO2. And you're going to look for the polyatomic ion NO2. Now, you're going to find that that is nitrite, okay? And it ends in ite. So writing the name as an acid, ite, becomes this. So it will be nitrous acid. Okay. For H3PO4, I'm going to go look for PO4 on my polyatomic list. That is phosphate. ate becomes ick. I ate something icky. All right. So it will be an phosphorus, sulfur, anything that has like a phosphorus in it or a sulfur in it. Those are a little weird when naming. So a lot of you are gonna say, oh, phosphoric acid. I will take it, but it is actually phosphoric acid. Okay, a little confusing, I know. CO3, okay, I'm gonna look for that one. Carbonate, so that will be carbonic acid. Okay. Last one on the left-hand column, H2S. Okay, so that's a binary acid. Some people get confused if there's a subscript of 2, that means nothing. Okay, that's just how the formula is written. So again, we're gonna start with hydro because it's binary. Sulfuric acid. Okay, so those are naming my acids, and then going from name to formula is the right-hand column. So this one is, you're kind of working backwards, all right? So you know, because they end in acid, you know that they are all going to start with a hydrogen, all right? So they're all gonna start with a hydrogen. So I'm gonna do hydrophosphoric acid first. So I know I'm gonna start with an H. Because I start with hydro in this name, I'm going to look at my main periodic table because it is a binary acid. So hydrophosphoric, phosphoric sounds like phosphorus, HP. Now, don't forget, we need to balance out the charges. So phosphorus has a charge of -3. And so in order for my compound to have their charges balance out, I need to have 3 hydrogens, because remember, hydrogen has a +1 charge. Okay, so that's a binary acid. With my other acids that I've pointed out, they don't start with hydro, so that means they're all going to be a hydrogen bonded to a polyatomic ion. So I'm going to look at the endings. So ick, is, ick, ick. Okay, so remember, I ate something icky. So that means that dichromic acid is a hydrogen bonded to dichromate. So I'm just going to go look at the back of my periodic table, find dichromate, and it tells me that it is Cr2O7 with a -2 charge. So I need to have 2 hydrogens to cancel out my dichromate charge, and then I'm going to add my polyatomic to the end. With chlorous acid, okay, chlorous is chlorite. Ite becomes is. So chlorite is ClO2 with a -1 charge. So my formula is going to be HClO2. All right. So I'm not going to do the rest of them just for timing's sake. If you look at the key that is on Canvas, those will have the answers. I want you to try the rest of the acids by yourself. All right, now we're going to move on to ionic compounds. So I'm not going to do all of these. Again, if you want to see the answers to all of them, you can look at the key. I'm only going to pick out a few of them to do. So I am going to do PbO2. I'm going to do BaCO3. And ammonium chloride. And I will also do silver chlorate. Okay. So first one, PbO2. So Pb is lead. And remember, lead is a transition metal. Okay, so transition metals are polyvalent, which means they could have multiple ions. They can have multiple charges. All right. So in the name, and you can probably see if you look on the right-hand column, you can see a few of them already do this. The name has to include the charge in Roman numerals, okay? So I need to look at the anion, the non-metal, to figure out what my charge is. So my non-metal is oxygen, okay? Oxygen has a -2 charge, and I have 2 oxygens, which means I have a total of -4. Now, I have 1 lead, okay? I don't have a subscript, which means I only have 1 lead. So my charge of my 1 lead has to balance out that -4 to equal 0, which means my lead has to have a charge of +4. So I'm going to write out lead, Roman numeral 4, in parentheses, oxide. Okay. And that's how you do it for anything that's transition metal, okay? So those groups, 3 through 12. All right. Next, we have BaCO3, okay? So if you notice, there are more than 2 atoms in this name. So first, Ba, that is barium. Barium is not a polyvalent metal, so I can just write barium. And then CO3. That is going to be a polyatomic ion, so I'm going to go look for CO3 on the back of my periodic table, and it is carbonate. So the name is just barium carbonate. All right, going to the right-hand column, ammonium chloride. All right, so ammonium, you are not going to find that on the main periodic table. You're going to find it in your polyatomics. That is NH4, and that has a +1 charge. Chloride. Chloride is Cl. Cl also has a -1 charge, so that works out really well. It is just going to be NH4Cl. I only need 1 of each, okay, because they cancel each other out. And remember, we do not include charges in the final formula. All right, last one, we're going to do silver chlorate. So remember, we also have that list of monovalent transition metals. So these are the transition metals that will always only have 1 charge. So we do not have to write a Roman numeral for them. So silver is one of them. Silver is Ag. Silver has a +1 charge. Again, this is also found on the back of your periodic table. And then chlorate, okay? So that 8 also tells me it's a polyatomic. So chlorate is ClO3 with a -1 charge. So again, a 1-to-1 ratio, which is really nice. My final formula is just going to be AgClO3. All right. So those are all the naming ones I'm going to do. Go ahead and look at the answer key on Canvas to check your work. We also have multiple worksheets on Canvas if you feel like you need more naming practice as well. All right, finally we're at the last page. Now, I'm not really going to go over the mistakes problem. You can look at the answer key for that, but here I've written a Lewis dot structure with multiple mistakes, okay? So you can rewrite it correctly. You can also write like what's wrong with it, what you should have done. I find this is a really good problem to do to make sure that you know kind of the concepts behind Lewis dot structures. Okay, so I highly recommend you do this and check it with the key. The conceptual questions I always find really important. So use your notes to answer these, okay? If you do not know the answers off the top of your head, through your notes, look through the periodic trends notes, look through your ionic bonding, your types of bonds notes, okay? All the answers will be on there, and your last resort is to look at the answer key, but I don't want you to just think about copying. I want you to like know why. Know the whys, okay? To these answers. So that is all for this review packet.